functionalities like CWEs. At the end, inherently is a pattern. It's not a technique to solve it, to find the CWEs. The way we think about it is about finding patterns. CVEs, which today it's maybe we just have a CVE. Let's say there's many other security advisories. GH, the others, the GitHub security advisory, the Ruby security advisory, so all of them. It's something that it's in your libraries. So libraries and code issues. But the thing about AI security is that first, even to detect these components, it's not enough to look in libraries. Libraries can give you a hint, and actually it's something, it's a great thing we do. We only using the libraries tell you the hints. I remember the day when we found you can do it. You can just take the libraries, even before you put some heavy scanners on other places. Just take the libraries and extract all the hints you can about the usage of AI, and that sounds like a great aurora for us. And that's maybe the first thing. But basically, how do you find models? Models is something, or you find it at the model artifact, which can be either the repository, in the container, in some S3 bucket, or spatial, models repositories. So that's a new place to take for models. And if it's, third party, if you're using some inference providers, which from my experience, most customers starting from using inference providers. Most companies, they start with some prototype and they will use the easiest, OpenAI, Azure OpenAI, Bedrock. They can. So that's something you can't find anywhere. Not an artifact. The only place is in the code. And none of our current solutions is positioned to find it. So you need a new solution. I think the AI security companies are going to be, products are going to be something like totally new, and that is going to be merged into the current DevSecOps and AppSec workflows.
Yeah, the way I think about it, or I always used to think about it, because my background is largely web security, which we would have a major distinction between dynamic and static security, right? So, I was at Fortify for a very long time, and there were the static people over there, and we were the dynamic people. I feel like the AI piece definitely is on the dynamic side. It has to be, right? So, rather than just web testing and API testing, it's got to be more comprehensive. So let's just jump right into.
We started with the static part of AI because we found that the biggest issue is threat modeling. Just to discover what you don't know you have. We found that it's not just a big issue; it's a huge issue because most companies just don't know what they have on the factor of 10. But then because of that, we moved into the we're now trying to offer both, because at the end of the day, AI and model is a bunch of numbers. And like code you can understand, you just can't understand it. And the only way is through a conversation, through dynamic simulating attacks, through pen testing, basically.
Yeah, absolutely. So let's think about that. So just talk me through how your solutions are set up. What is the basic tagline for it? Is it asset discovery? Are you discovering the structure of the application? Are you enumerating controls? Are you testing controls? What exactly is it that the suite does?
So it's kind of both. We're starting from statically scanning all the AI assets, all the AI resources, components, you can call it in different names, and to find all the AI you have. Usually at this stage, we find that usually we start like average company will say, we have some AI components, some AI-driven applications. Then where we do the like initial scan, we found it's more than that by factor of 10. And that's every time exciting to see, like, and you know, in the security, it's really easy to say that it's bad, but actually it's pretty amazing how the industry is trying to push hard, to push forward. So even without the security knowing, everyone just trying to use it, trying to make smarter applications and more valuable products. So we detect it. And then the question is, if I have DeepSeek and it's a RAG, maybe it's bad because RAG connected to data, you know you don't want to leak this data, and you're very concerned about DeepSeek. Let's say China, which is then it's the opposite. You probably want to use DeepSeek. So you just want to know what you have. Then you want to detect all the risks you have in these components, which is kind of a composition analysis. When you think about it in deeply, not only libraries in SEA, and that's amazing. You find legal risk, you find security risk for all these components. It can be models, agents, MCP servers, agent tools.
And how are you getting all the components? Are they providing them to you? Or are you getting them dynamically? Like, how are you getting these from the customer?
So we started with taking the hints from the open source libraries. And then we use these hints to look into the code, find all the components in code. If you're using self-hosted models or like open source models, we'll look for artifacts. So we'll find the file that from the magic of the file, from the headers of the file, we know it's a model, and then we have some fingerprinting technique to match it into the actual file it's inherit from. So if you took a file, fine-tuned it, took something for Hugging Face, fine-tuned it, and using it, we'll tell you about this file. And that is a lazy Hugging Face model, and hopefully not malicious one.
Oh, interesting. I mean, that's an offering by itself, right? Just like asset discovery.
Of course. You'll be surprised by how much, there's the proportion between what you know and what you don't know is large. It's pretty amazing.
Yeah, whenever I do security assessments, I usually have a really large visual that I'm building out throughout the week. And honestly, it's just laying out what the application does. It just lays out what the functionality is, where the data is flowing. And as I'm interviewing more and more developers and more people in the company, I just bring them in and show them this thing, and they're like, oh, everyone starts taking pictures. They start taking pictures, they're like, oh yeah. So, because they don't have any documentation that's actually good. And it turns out if you just see it, if you just visualize it, you're like, it's obvious to everyone who walks in the room that this is a problem. And, when it's not visualized, or it's not explicitly laid out, you just miss the stuff. Okay, so you have the list of components.
By the way, it's I like all the trend of showing topology.
Yes.
What you have. Yeah, I love this trend. I think there's a really large debate in the security industry because people say, at the end of the day, it's not showing the data, you need tables. So there's something about visualizations that has give you the value, shows it in a different way. And it's funny.
I would just show an arrow, and I would color code the arrows. I would have the data classification for the company on the board, and if it's one of the last two data classification, sensitive, secret, whatever their classification is, then I would just have all the connecting dots or the connecting arrows be red. They're like, why are these red? Because Sarah over here or John over here said that type of data classification is included in this data. And suddenly, after you talk to 20 different people, the whole board's red. Right, the whole board's red, and they're like, okay, I didn't realize the problem was this bad. Yeah, and then those documents end up being used as the official document for the application going forward. So I feel like this is absolutely needed, especially for AI. When I talk to people about AI implementations, I'm just like, show me exactly where the agent is in this workflow. Show me exactly which APIs it has access to. And as they start writing it down, they're like, oh, well, I think I see the problem. I haven't even said anything yet.
Yes, it's amazing. You know, I love threat modeling. I love like doing it with customers, and you study from it so much.
Yeah, absolutely.
And at the end of the day, like it's not enough because you need to detect the issues. So there's malicious models, which is like,
so with Megger, it sometimes gets confused when doing a prospective earth fault current test and gets stuck here 0.1 23 kilo ohms. So guy on the helpline said to me, you've got to put it back to low ohms continuity and zero the lead. Don't think there's anywhere on the manuals that they teach you about that.
Code that is serialized into some like some opcodes.
It's always the parsers. It's always the parsers.
Yes.
Yeah.
And it can pull code. Theoretically, it can pull another binary from remote and run it.
Yeah.
So it can be super malicious.
Yeah, absolutely.
There's also like another risk, like other classic vulnerabilities. Only this week, I saw a company that scanned all the papers, all the academic papers, and tried to extract the existing attacks and to map, attacks to models. I think it's still not, we're still not there at the end of the game. It's not like SEA that you have so many security advisories, but I think we're getting there. And with threat teaming, we're for sure more mature as an industry.
Yeah. Okay, so let's say someone, what does an ideal customer look like for you? Like in terms of, they come to you and they say, I have this problem or this problem or this problem, and you say, okay, perfect. That's exactly what we do. What would those problems look like, and what would you tell them the solution is?
There's two types of companies. I see it's companies that are concerned about the app, but they don't know what to do.
That's what you should be getting.
Pre-threat modeling stage. That's a stage where
For a TN
first thing you need to do is
CS
cover everything you have,
system.
all the agent models. Usually,
So a little faux pas on Megger's meters.
We're only using, Azure OpenAI, and then we'll find many like a Hugging Face model, DeepSeek, and other inference providers. And that's the first stage. And once we help to do the threat modeling, we see how the companies start like thinking and getting more advanced. And the other type of companies are a bit more sophisticated ones, where they already have some like 2 to 3, let's say, or a few like major AI-driven products. They know about them. They already like threat model them. So the discovery will still help them a lot. But they're more advanced. They know they have some, let's say, tax application reviewer, automatic reviewer, that like is very smart, but it's very risky because it's a PDF and something can happen. Usually they wouldn't know exactly what the risks. They wouldn't know that what they need is, something that will simulate attacks of sending PDF with an image. Inside the image, it will have some prompt injection. But they will heard about the OWASP top 10 for LLM applications, which is, by the way, great list of threats. Great awareness.
Yeah, that makes sense.
And then we'll tell them, hey, you have here potential malicious model, check it. You have here DeepSeek, and that's the findings from the dynamic scanning of the all the attack simulations. Okay. Then we need to fine tune what's the right attacks, what's the most important attacks to check.
Nice. Okay, and then what is the product? Like, what does the product suite do? Like, what are the pieces of functionality?
So basically what we spoke about, it starts with discovery of all the components, then it moves to the risk of each component individually. Once you know about all the components, you need somehow to connect them into a behavioral risk. And to understand, to contextualize all the risk of the entire components together. Because you can have system prompt, you can have a model, and you can have some, RAG that connects them to a database. But unless you understand you have this database, this system prompt with this model, that's the only way to understand that you have context leakage. And so for that, we have these behavioral risk, automatic red teaming, attack simulations. And to wrap everything, we're doing a mitigation, what we call governance and mitigations, where you can create policies to prevent, let's say, if it's running DeepSeek, block it, this spatial combination. And in the near future, we're going to release the ability to what we call guide rails, which is not guardrails, it's guide rails.
Interesting.
The concept of mitigating, putting like mitigations into the code. Not like a firewall.
Like dynamic detections as
see water bonding there. Can't really get to it. Yes. And see it. Just can't ascertain if it's on there. So we'll have to do a long lead.
You want to make sure one user can't access a different user data. So old problem with a new suit, let's call it. So
yeah,
we see so many nutrients, and exactly like you said before, so many same problems and new problems, which are basically the same. So that's one.
Yeah.
I think we need to remember it, that all the new things are basically old.
Yeah, IAM, like you're talking about. Yeah, I think the distinction between what an agent is doing and making sure it's not acting on behalf of an actual human, right? Making non-human identity versus human identities and making those distinctions, having separate policies for those. I think that's going to be important.
Yes, and like same concept. You want multi-tenant also for agent. You want permissions also for agent.
Separation of duties, like you said, all the old stuff we have to re-implement. Relearning the lessons from 25 years.
Exactly, and I think like if you look on the new construction classes, you see that multiple agents, of course, multiple agents, frameworks, agent orchestration, create more issues because it's way more complicated to understand how it works. And the communication between agents make the exploit complicated. It's very maybe more complicated, but like very similar to what you have when you try to exploit memory corruptions, that you try to jump between different places in the program in order to finally run the code. So it's very similar to here. If the code is, if you have more attack surface, when you have the code is larger, you have more places, more gadgets that you can, like more places you can jump between each other until you run your code. Here you have many agents, so you need just to find the agent, to send the right prompt into to run the code.
I think it's worse, like you said. I think it's worse with multi-agent because that's more opportunities for tricking. Like you might have a smart one. So a prompt injection might not detonate with the first one you're talking to, but it might pass it along to a dumber one behind it. And that one it will detonate on. Yeah, interesting.
Also, if you think about it, when you have more components that's speaking with each other, it's hard to track what's the purpose of each one. So you're going to have these, let's call it small drifts in the communication between them. There's one that should do X, the one should do Y, but they will have somewhere like some very small interaction that will probably be exploitable.
Yeah.
Because for each one individually is totally okay. It looks fine.
Yeah. So for the CISOs that are listening, like what's the one piece of advice? Like what's the one thing you would say to someone who's implementing AI or trying to secure it?
I would say the easiest thing to do is, at least from my experience, is to try to create really hard forcing policies. It prevents everything, blocks everything, and that's really easy. But I think the right way to go is to create integrated workflows like any other security issues, and it will help to enable developers and enable the products to be really good and valuable, AI-driven, and just safe. And it's right for everything, and I think especially for AI. And I see it firsthand, maybe a bit too much, unfortunately.
Yeah, that makes sense. And where can people learn more about the company?
So Meta is Ask the Company, traditional Ask the Company, one of the first scale vendors that grew into, SaaS, CA, container scan, container image scanning, like I spoke before, about the reachability technology that we got acquired for, and now also AI security. We love what we do. We have a lot of customers, and I think we're the first AI security vendor in the market. We're doing a shift left, so we're really proud about it and hoping to make worse in the industry about it.
Awesome.
Confirmed.
Well, Burrell, it was great chatting with you, and look forward to chatting.
Gas.
Lovely. It's my pleasure.
All right, take care.
Thank you.
Unsupervised Learning is produced on Hindenburg Pro using an SM7B microphone. The video version of the podcast is available on the Unsupervised Learning YouTube channel, and the text version with full links and notes is available at danielmitzel.com/newsletter. We'll see you next time. Unsupervised Learning is a podcast about ideas and trends in cybersecurity, national security, AI, technology, and society, and how best to upgrade ourselves to be ready for what's coming. So here we are at the house. It is after RSA.